Greetings everyone. Have you ever picked up an arrestor datasheet and had a hard time understanding some of the terms and numbers? Don't feel alone, they are quite confusing. This video and its associated article will make future arrestor datasheet review much easier for you. This video is the last in a series on arrestors and quality. The earlier 3 videos are available for you to view for a better understanding on how to find a good quality arrestor and supplier. Let's start with the arrestor recommendation table that comes in different forms but all have similar columns. If you are new to arrestors, this table will help you select the arrestor rating needed for your applications. Once you know the system voltage, you can select the value on the left column. Then you need to know a bit about the system neutral configuration at the power source transformer. If the system is the more common distribution system in the US, then it is a 4-wire system with a neutral carried along the full length of the system. Or if the neutral is grounded at many locations along the system, then column 3 is the one to choose your rating. Column 4 and 5 are for other systems and covered in more detail in the paper. Next, let's discuss the discharge voltage tables. The most basic reason for purchasing an arrestor is for surge protection. This table tells you how well the arrestor in question protects equipment. It is the discharge voltage that you are paying for when you make that purchase, also called the clamping voltage or the residual voltage. Note, there are 2 numbers for arrestor rating. This is because most arrestors do indeed have 2 AC ratings. The first number is the AC rating of the arrestor and dates back to the previous vintage of arrestors. The second number is the MCOV, or the maximum continuing operating voltage, and is the rating that is of the most importance in selecting an arrestor. If you are comparing arrestor characteristics of different manufacturers, the MCOV rating of the unit being compared should be the same. Moving to Group 4, we find the most important columns of this table. This section tells you what the clamping voltage or discharge voltage of the arrestor will be for various surges. The surges in this case are similar to lightning and are referred to as the 8 by 20 microsecond discharge voltages. The 8 by 20 microsecond current wave is a standard surge that has been used in the lab for decades and allows users to compare similar characteristics. The 10 kA value is the discharge voltage that is most commonly used to compare arrestors. This is the voltage produced across the arrestor when 10,000 amps are forced through the device. In this hypothetical table, a 10 kV rated 8.4 kV MCOV arrestor has a 10 kA discharge voltage of 25.7 kV. The other columns are also important and are covered in the article. Next, let's discuss the short circuit ratings. Typically, arrestor datasheets have a table somewhere that discusses the short circuit ratings. This rating is important because it tells us what the maximum fault current withstand that the arrestor is capable of. Model A in this case can withstand a short circuit current up to 15,000 amps for 0.2 seconds without sending fractured parts outside a circle with a radius equal to the height of the arrestor. This is a very complicated test and very difficult to run, but it gives us this important information. If the available fault current on your system is above the rating of the arrestor, then you need to select a different arrestor. Next, let's talk about the energy handling table. Arrestor energy handling capability is one of the most difficult characteristics to understand on the datasheet. It is now complicated by the fact that changes in the way arrestors are rated have just taken place. Some older datasheets will be similar to the table on the left, while the same arrestors rated under the new system may look like the table on the right. In the past, station arrestors have only had one energy rating in kilojoules per kV of MCOV, while now they have an additional rating that is a measure of the maximum current they can carry from a surge. Because the wave shapes of the test current can be variable, the unit of measure of the current is the integral of the current, which is charge. Charge is measured in coulombs, so the table shows the single impulse charge transfer capability in coulombs. In conclusion, the datasheet article contains much more than we have covered in this video, so you are encouraged to refer to the article this video is based on with more in-depth understanding. This video has been brought to you by members of the National Electrical Manufacturers Association. They urge you to seek good quality arrestor suppliers that provide you quality datasheets. And as always, they urge you to keep on learning.